Hey, what's up? It's Ryan. Today we're going to go over conic sections, in particular circles. Circles come up on a variety of questions. They're super common on SATs, they're super common on math team questions, and obviously tests in Algebra 2. So it's super important that we understand circles, the equations associated with them, and so hopefully by the end of this lecture we can get a better idea and familiarity with circles. Okay, so first of all, what are conic sections? Well, conic sections are formed by the intersection or the cross section of a plane and a double napped right cone. So basically, if we look at this shape right here, we have almost like these two cones that are almost like reflected, and they go on infinitely upwards here. They go on infinitely. And here we have this plane, right? We can see by this dotted line. And so essentially what we're doing is we're changing the angle of this plane. And what this plane is doing is we're slicing through this double napped right cone. And what we're going to do is we're going to see as we change the angle that we slice through this double napped right cone, how does that cross section change? So what that means is how does the shape, once we take those two sort of pieces apart, or it could be more pieces, here it's going to be 4, but once we take those pieces apart, what is sort of the cut off part going to look like? What shape, what conic section is it going to form? So here in this first example, we are slicing completely horizontally, and so what that's going to form is a circle, a complete circle. So if we just take even if we just take a regular cone and we slice completely horizontally and we remove those two pieces, we're going to have a circle. Here, when we change the angle that we slice at, this axis is now going to be a little bit longer than before, right? Rather than here where this axis. Now this axis is going to be longer than this axis, and that's going to create an ellipse. Here, when we slice almost vertically but it's still at an angle, it's going to create something you guys are super common with, and that's going to be a parabola. And if we slice completely vertically, so at a 90-degree angle, we're going to intersect at two different places, and that's going to create something called a hyperbola. And we'll talk about each of these and go in depth in each of these conic sections later, but we should be pretty familiar with parabolas. Thinking in terms of 3D can be kind of hard. Sometimes it's helpful to have some hands-on representations, but thinking in 3D is going to be super helpful, especially once you get to multivariable calculus and linear algebra, when we expand from just, this two-dimensional Cartesian plane. Once we start expanding to 3D, it's going to get a lot more complicated. But if we can sort of think and visualize this and the shapes we get once we slice this double napped right cone in either halves or in fourths in this case, it's going to be super helpful. Okay, so the standard form of the equation of a circle. Our standard form is going to be x minus h squared plus y minus k squared equals, and I'm going to put r squared here. So where hk is the center of the circle and r is the radius. So here we can notice just from analyzing this equation for a circle that this is going to be similar to almost like, remember the vertex form for a parabola and how that horizontal shift, that inside part, what we had a negative sign, we subtracted our axis of symmetry. This is super similar. So remember, you just have to be conscious that this is our equation for a circle. So if you see plus x plus 2 here, know that our h value is actually going to be negative 2. And so it's going to actually be the opposite sign. So yeah, just be mindful of that. Okay, so let's start to graph some of these circles. So what's our center? Well, what's our h value? X minus h. In this case, it's x minus 1, so h is going to be 1. And what's our k value? Y minus k. Y minus 2. Our k value is 2. I'm just going to put that point right here. And here we're just going to assume every single unit is 1. Every single box is 1 long. Now here, this is equal to 64. And one thing I see a lot, especially on SATs, they'll pick numbers like 9 here. And actually, in the second question, we'll go into why they pick 9 and how it can become, how they can sort of trick you by doing so. But this 64 is equal to r squared, right? 64 is equal to this value. So if we take the square root of both sides, we're gonna get r equals 8. So essentially what we can do is we can count 8 in both to the left, right, up, down, create some points. So 1, 2, 3, 4, 5, 6, 7, 8. I think that's right. Let me just make sure. Yep. Right, a circle is comprised of a bunch of different points that are equidistant from our center. So they're the same length. So we could count 8 units out in this direction or 8 units out in this direction, but it's just going to be easier if we do it at 0, 90, 180, and 270 degrees. So we have 4, and then we have another 4. Okay. 2, 3. Okay. So these are 4 points, and I'm going to attempt to make a circle, but this is probably not going to be great. Oops. Yeah, that's not too good. But hopefully you can get the idea. When you have the paper in hand, it'll be much easier. Yeah, that's just the basic idea, right? All these things should be rounded. We know what a circle looks like. Okay, so let's move on to number 2. Here, we don't have anything. Here we had x minus 1. Up here we have x minus h. So what's our h value going to be here? Well, x squared is just another way of writing x minus 0 squared. So what's our h value here? Yeah, 0. So what's our k value here where we have y plus 5? Well, remember that it's y minus k. So here, essentially what we're saying is y minus negative 5. So this is going to be 0, negative 5. Now, I said SAT, people creating those tests, and Algebra 2 teachers, they choose 9 or things like 16 or 4 is also super common in particular. And that's because sometimes it's super easy to see this 9 and say 9's our radius, and instead of saying r equals 9 or r squared equals 9, they're going to say r equals 9. And so then they're going to square 9 and say 81, when in fact we're taking the square root. So be mindful of that. Whatever this entire left side is going to be equal to, take the square root of that to get your radius. So in this case, the square root of 9 is going to be 3. Just a little tip, because it can be easy to switch the two up, and especially with lower numbers like 4 or 9, it would not seem that crazy if your radius is 4 or 9, when in fact it's actually equal to 2 or 3. Okay, so our center was at 0, -5. So we're going to put that down here. 4, 5. And then our radius is going to be 3. So I'm going to choose right here. 4 points there. And I'm going to try to connect the dots better this time. Yeah, that wasn't bad. That wasn't bad at all. Okay, but this is what our graph is going to look like. Okay, so now we're going to start rewriting equations in standard form. So here, how do we make this equation, 3x squared plus 3y equals 192, look a little bit more like something up here? Well, first thing we need to handle, and it's actually the only thing we need to handle, are these 3's out front. So I'm going to divide both sides by 3. So we're going to get x squared plus y squared equals 64. And that's all we need to do. We don't need to do anything else. So that's just our answer. Ooh, that was horrible. I'm sorry about that. That's so bad, but it's all right. Okay, 4. Well, this looks complicated. We have a lot going on here. So first thing I'm going to do, I want to move this y to the left side. So I'm going to keep this x minus 4 squared. But I'm going to add I'm going to add y squared to both sides. And that's going to cancel this y out, right? And at the same time, hopefully you're comfortable with this, I'm going to add 52 to both sides. And so by adding 52 to this side, I'm going to cancel out that 52. And I'm going to get 52 plus 2, which is 54. And that should give us our correct answer. Now, if we go down to 5, this is going to be a little bit more involved. And so we're actually going to need to complete the square. So I'm going to rewrite this I'm going to rewrite this real quick. I'm going to say x squared plus 6x plus something. I'm going to leave that space blank, plus y squared plus 2y. And actually here I'm going to leave space for something else, but I'm going to move this 6 to the other side. So I'm going to subtract 6 from both sides. Okay, so now for completing the square, what I want you to do is just focus on this right here for now. Completing the square or a perfect square, first of all, is going to look something like this, where we have, for example, x plus 2 squared. And so when we FOIL this all out, we're going to get x squared plus 4x plus 4. Oops. Okay. And so, essentially, if we look at this, right here, if we look at this 2 and this 4, this 2 is going to equal b over 2, 4 over 2, right? And this value is going to equal b over 2 squared. So essentially what we're doing is we're looking at, essentially what we're doing is we're looking at our b value. Looking at our b value down here, and we're saying, first of all, what's b over 2? So we're going to say x, because eventually we want to get this into the form x plus b over 2 squared, right? And we have to have b over 2 because once we FOIL it out, that's going to give us this right here. And so what's b over 2 in this case? It's going to be 6 over 2, so we're going to have x plus 3 squared. Oh Lord. X plus 3 squared. And that's going to give us x squared plus 6x plus 9. And that's what we want, this plus 9. So I'm going to put plus 9 in here. For this y part, we're going to do the same thing. We have y plus b over 2. Sorry, that looks like a 10, but it's a b. Y plus b over 2 squared. B in this case is going to be 2, so we're going to say y plus 2 over 2, which is 1. Y plus 1 squared. And that's going to give us y squared plus 2y plus 1. So we have that plus 1, and we're just going to put that right here. Now, one important thing, and I should have actually told you guys this initially, but whenever we do something to one side, we need to do it to the other, right? Whenever we add 9 to one side, we need to add 9 to the other. It's just properties of equality to sort of maintain this balance sign that we call the equal sign. So I added 9 to this side, so I have to add 9 to this side. I added 1 to this side, so I have to add 1 to this side. So let's look at this underlined part. We did this before. What's this in factored form as a perfect square? Well, it's x plus b over 2 squared. B over 2 is 6 over 2, which is x plus 3 squared. Sorry, I don't know why this does like this. Sorry, it's tripping. Okay, and for this y portion, we're going to do y plus b over 2 squared. We have y plus, our b value is 2, so 2 over 2 is 1, y plus 1 squared. And that's going to be equal to negative 6 plus 10, essentially, where we get positive 4. And this is going to be our standard form. Okay, we're going to do a problem sort of similar to that here. So first, I'm going to separate these two. I'm going to say x squared minus 14x minus 14x plus something plus y squared plus 4y plus something is going to be equal to 28. So what we're putting in these spots, right? If we look back here, this is b over 2. This is b. And this number right here is going to be b over 2 squared. So what I'm going to do is I'm going to look at this, our b value here, negative 14, and I'm going to divide that by 2. So negative 14 divided by 2 is negative 7, and I'm going to square that. Negative 7 squared is going to be 49, so I'm going to say plus 49. And actually, while we're at it, we're just going to write it right here, plus 49. Hopefully you guys can see that. For some reason, this is all weird, but it's all right. Here, our b value is 4, so b over 2 is going to be 4 over 2, which is going to give us 2. 2 squared is 4, so we're going to do plus 4. So I'm going to factor this, right? This is going to come out to x plus b over 2 squared. In this case, our b value is negative, so it's actually going to look like x minus 7, because our b value of negative 14 over 2 is negative 7, so x plus negative 7 is the same thing as x minus 7, plus y plus b over 2, which is going to give us 4. Sorry, I was going to write b over 2. Jeez, oh Lord. Okay. Y plus 2, 4 over 2, right? Y plus 2 squared. And this gives us 28 plus 4, 32. And then 32 plus 49 should give us 81, I believe. I just want to check that just to be sure. Yeah, no, it is. Okay. So this is going to be our standard form. So let's just recall what the standard form of an equation of a circle is, because this is super important. It's going to be x minus h squared plus x minus k squared equals r squared. Okay. Write the center, write each circle equation in standard form with the given information. So our center is negative 2, negative 7. Let's first deal with that. So x minus negative 2 squared. Hopefully you realize that this is just the same thing as saying x plus 2. So I'm going to rewrite it as x plus 2. Sorry, and I'm just going to do that. X plus 2 squared plus y plus 7 squared, right? Because we're doing, ooh, Lord, I'm sorry about this. I'm sorry about that, y'all. This is y. Y plus 7 squared, because we're doing y minus negative 7. And this is going to give us a radius of 16, so that means r equals 16. R equals 16, so r squared is going to be 256. This can be super easy to put 16 or maybe put 4, but remember that whatever number this is equal to, we need to take the square root to get the radius. And if we're given the radius, we need to square it to get whatever this right side of the equation is. It can be super easy to mix up, and here they're just trying to trick you into thinking that maybe you should put 4, but no. Okay, here our center is negative 2, 6, so we're going to have x plus 2, right? Because we're doing x minus negative 2. So x plus 2 squared plus y minus 6 squared equals our diameter is root 30. So, right, what's our diameter on a circle? It's basically the longest chord, which is to say it's going from edge to edge through the center of the circle. And so our diameter is this entire length. Our radius is just this length. So this is R, whereas this is D. So our radius is half of our diameter. So R equals root 30 over 2. So R squared is going to be 30 over 4. Because essentially when we're squaring both sides, I could do that, but I'm not going to. We are squaring the top and squaring the bottom. And if we square something that's already being square rooted, they're both going to cancel out. So we get 30 over 4, which is the same thing as 15 over 2, which is the same thing as 7.5. Actually, I'm just going to say 15 over 2. Sometimes it can be helpful in conic equations just to leave it as a fraction. Okay, 15 over 2. Here, our center is negative 8, 0. So I'm going to write x plus 8 squared. And I'm going to have y minus 0, y plus 0. It's all going to be the same. It does not matter. It does not matter if we add 0 or subtract 0. It's not going to change anything. So I'm just going to say plus y squared. And our circumference is 10 pi. Our circumference, if we remember this, is going to be almost like, you can think of it as the perimeter of a circle, almost. It's going to be, how long is this arc length? But this arc goes around the entire circle. And here, one equation for our circumference is going to be 2 pi r, or the diameter times pi, but the diameter is equal to 2r. So here, if our circumference is equal to 10 pi, we have 10 pi equals 2 pi r. These pi's cancel out. And we divide by 2. Hopefully you can see we get r equals 5. So if we look back up on our equation, we have this is equal to r squared. So this is going to be equal to 5 squared. And we're going to get 25. Okay. Here, the center is negative 5, 6. So we have x plus 5 squared plus y minus 6 squared. And our area is 10 pi root 2. So our area, oh gosh, I don't even know what I was doing there. Our area is going to be equal to pi r squared. So if our area is 10 pi square root 2, we're going to have that equal to pi r squared. We can cancel out both of these pi's. And now what I'm going to do, we're left with 10 root 2 equals r squared. What I'm going to do is I'm going to make this under one radical. So essentially what I'm going to do is I'm going to say 10 is equal to root 100 times root 2. And that's going to be equal to root 200 just by multiplying those two. So if we go back up here, I'm going to say root 200 equals r squared. Actually, that wasn't even necessary. We can just say this is equal to 10 root 2. And then we can do our own work later to actually see what the radius is if we need to. Ooh, 10 root 2. I'm sorry, Lord. Okay, so this is our answer. Okay. So what's our distance formula? Our distance formula is going to be, it's going to be related to our Pythagorean theorem formula. All right, our Pythagorean theorem has, I'm going to write it off to the side. Here we have a right angle. Why does it do that? Here we have a right angle where this is side A and this is side B and this is side C. The Pythagorean theorem tells us a squared plus b squared equals c squared. We can rewrite this as c equals square root of a squared plus b squared. So what if I told you, instead of saying instead of saying A, and instead of saying B, and instead of saying D, we replace this with X, Y, and D. And maybe it might be more fitting to say delta X, or the change in X. But I'm actually just going, we'll say delta X. And basically what this just means is how X changes, how much did X change by. And so essentially what we can write is D equals the change in X squared plus the change in Y squared, right? Just by substituting this here. And so how do we find the change in X or the change in Y? Well, we're going to pick 2 points. And we're going to say, for example, if we have x1 and x2, we're going to have x1 minus x2 squared plus y1 minus y2 squared. So essentially what this is saying is, just to break this down, because maybe you've seen delta X in your physics class or something like that. If we have 2 points here and we're trying to find the distance between them, we're going to see, hey, what's their X value? And let's say this is x1 and this is x2. We're going to subtract the 2 to see this distance, this change in X, this delta X. And then we're going to square that, because what we're doing right here is we're creating a triangle to find, oh God, sorry, I really just can't with this. Lord of mercy. What is happening? Okay. We are going to create this triangle. And we're going to find what this top length is. I'm sorry, I don't know why this is bugging, but it's alright. Okay, so our midpoint formula is going to be essentially, oh God. Our midpoint formula is going to be x1 plus x2 over 2 and y1 plus y2 over 2. So what we're saying here is when we create a graph, right? Let's create a graph with 2 points, just like we did before. If we're trying to find the midpoint between them, right? The midpoint. What we're doing is we're first going to find what the average is between these two x values. So we're saying we're adding, it's almost like a mean, but we only have 2 points. We're saying we're adding the x value of one and the x value of another, and then dividing by 2 to find the middle point. So I know it's going to be along this line. And I'm doing the same with the y, where I'm adding the y value of one and the y value of another, then dividing by 2 to find the middle in between there, and we're gonna get like a midpoint right there. And so we'll use this a lot with circles. So here, we're given the center. We're given that the center of a circle is -5, -6, and a point on the circle is 2, 3. And so what we're going to do is we need to find the distance between those, right? We're given, if we visualize this, we're given a point here, and then maybe we're given a point on the edge, and so we're going to try to find this distance so we can find the radius. And so we use that, we use the distance formula. So we're going to say D equals, in this case, D is going to equal R. We're going to say equals x1 minus x2. So I'm going to say -5, and it does not matter the order you do this, but -5 minus 2 squared plus -6 minus 3 squared. And when I say it does not matter the order, you could do x1 minus x2 and y1 minus y2, or you could do y2 minus x1, or sorry, I mean x2 minus x1 or y2 minus y1, as long as you just stay consistent in both of these. So this is going to give us -5 minus 2 is going to give us -7. -7 squared is 49 plus -6 minus 3 is -9. -9 squared is 81. And 49 plus 81 is going to give us 130. Root 130. So if this is equal to R, right, this is equal to R squared is going to be root 130 squared, which is just going to give us 130. So if we use what we learned before, our center is -5, -6, so we're going to do x plus 5 squared plus y plus 6. No, sorry, I think my computer might be dying. I'm back. My computer may or may not have just died. Okay, so we have y plus 6, right? Because we have y minus -6, y minus k. So we're going to have y plus 6 squared, and that's going to be equal to our r squared, which is 130. Our center here for this next problem is 8, -3, and our point on the circle is 2, -2. And so this is very similar to almost the exact same thing as what we just did. So we're going to have the exact same procedure. We're going to say D equals R in this case, and D equals the square root of, I'm going to say 8 minus 2 squared plus -3 minus -2 squared. And so essentially what we get here is the square root of 6 squared, which is 36, plus -3 minus -2, which is -3 plus 2. And so we get -1, and -1 squared is just 1. So we're going to get R equals root 37. So R squared is going to equal 37, right? We square root 37 and we get 37. We plug this into our formula for a circle, x minus 8 squared. We should be a little bit more comfortable with this equation now. Y minus -3, so y plus 3 squared equals R squared, which in this case is 37. So here we're given 2 endpoints of a diameter on a circle. So essentially what we can do from here, we're given this point, we're given this point. So by finding the distance between these 2 points, we can divide that distance in half to find the radius. But we can also find the coordinates for this center, x, y, by using the midpoint formula. So I'm first going to find the center of this circle using the midpoint formula. So if we scroll up here, our midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So here, our center is going to be x1 plus x2 over 2, y1 plus y2 over 2. This is going to give us 1 plus -5 over 2, and then -16 plus 4 over 2. That's going to give us, here if we simplify, that's going to be 1 minus 5, -4 over 2, and -16 plus 4, which is -14, or sorry, -12. Lord, making a lot of mistakes today. -12 over 2. And this simplifies to -2, -6. Okay, so I'm going to save some space, erase a lot of this, and move our center up. Our center is -2, -6. Okay, so now that we have the center, what we could do is we could find the distance between these 2 points and then divide by 2. Or now that we just have the center, we can just find the distance between these 2 points. So I'm going to do the latter of those 2 options. And so the way we're going to do that is like we did before, using the distance formula. So we do -2 minus, and in this case I'm actually just going to use this point, but it does not matter which point you use. They're both going to give you the right answer. We're going to do -2 minus 1 squared plus plus -6 minus -16 and all of that squared. So what we're going to get here is -2 minus 1 is -3. -3 squared is 9. And -6 minus -16 is the same thing as -6 plus 16. So we get 10 plus 10 squared, which is 100. This is all equal to r. So r squared, I should probably write that r is now equal to √109. So r squared is going to be 109. And now we have this formula where we can plug this back in. We say x minus -2, so it's x plus 2 squared plus y minus -6, or y plus 6 squared equals r squared, which in this case is 109. Perfect. Okay, so last problem. Let's use the midpoint formula. We are going to do, for our x value, it's going to be 6 plus -4 over 2. And then -3 plus 9 over 2. That's going to give us 2 over 2, and then 6 over 2, which is just going to be the same thing as 1, 3. So our center is 1, 3. Okay. And now we're going to use the distance formula to find what the radius is. And so the way we're going to do that is we're going to use d equals r equals this entire thing, where I'm going to use this equation in this case. It does not matter, again, what point you use. So I'm going to do 1 minus 6 squared plus 3 minus -3 squared. And this equals -5 squared, which is just 25. And this is 3 minus -3, which is the same thing as saying 3 plus 3, so 6 squared plus 36. And that's going to give us 61. √61 is our r. So our r squared is 61. That's going to mean we do x minus our center, x minus 1 squared plus y minus 3 squared equals r squared, which is 61. Okay, so hopefully you feel a little bit more with circles, the equation for a circle, maybe some completing the square, comfortable with distance formula, midpoint formula. If you have any questions, go to your teacher, go to Mr. Whitaker, go to the tutoring center, consult online resources, and of course, feel free to reach out to me. Thank you. Have a good day.